Great. Good to be back. And I've got two of my absolute favorite people who are synonymous with droidCon, Chet and Romain. Thanks for being here, both of you.
Thanks for having us. And
great to be here.
On us.
I mentioned before in the back room, it was a pleasure to introduce you, the men who actually really need no introduction. My work is going to be done very quickly, because if you have been at a droidCon or heard of droidCon any time in the last 10, 11 years, then you know the names Chet and Romain, and you see what they've done, and it's been a lot of fun having you both, and we're thrilled to have you back again talking about modern Android development. So thanks for being here. We appreciate it.
Happy to be here, especially since it was so easy to get there.
We tried to reduce your travel this year.
You did.
You did a good job.
I just want to reiterate something very briefly that I touched on in my very brief welcome address remarks. Chet and Romain are going to be sticking around actually for quite a bit of the morning. They will be doing their keynote. We'll have a short break, and they will be joining us and a number of people from the Google team doing a modern Android development panel discussion. So you will see next to the streaming window here, the Slido links. As they address something, if something piques your interest or you have a question about it, please feel free to throw that in the Slido link there, ask the questions. The questions, though, the Q&A portion is gonna roll over into the panel discussion. And I think that was because you were possibly scared to answer questions directly, right, without the backup people? Or
I'm terribly nervous giving these talks, so I'd really rather not. Yeah.
We try to take care of you, Chet. So let's.
Yeah, no, it's going to be better to do it in the panel because Android is huge, right? So if you ask a random question, there's a really good chance that I will not know the answer. Romain may not know the answer, but if we get a larger group of people, then there's a better chance that we can have a good discussion about it.
All right. Well, hey, I'm going to let our technicians boot me from the stage, get me out of here as fast as possible so you can take over. Again, thanks so much for being here. I look forward to listening to your talk, and we'll see you on the other side in the panel.
Awesome. Thanks, Greg.
All right. Bye-bye.
Hey, everybody. Thanks for having us to another droidCon. We have indeed been to a bunch of droidCons, but not all of them. So it's awesome to have these like time zone wide droidCons where we can pretend that we're attending all of them all at the same time in parallel. We're probably using like coroutines or something. I am Chet Haase. I'm on the developer relations team where I talk about Android.
And I'm Romain on the Android Toolkit team, which means that we do a lot of things that have nothing to do with the UI Toolkit. So Jetpack stuff.
So we are going to talk about modern Android development today. We have this presentation called Modern Android Development, but it turns out we have talked about this before. In fact, a couple of years ago, Android Makers in Paris, we talked about it for the first time. We had this presentation called Modern Android Development. And then I think the following week, also in Paris, we talked about it at Devox in France, and then at Google I/O the next month. And then in 2019, we talked about it at Android Developer Summit. I think we also talked about it at a conference in Greece and probably, I don't know, 5 or 6 other places. So we've done this before. So you would think maybe this is a repeat, but it's a different version, right? The former version that we happen to use the same name for was basically looking at some of the stuff that we used to do and then saying, well, there's newer ways to do this, and sort of doing a compare and contrast. And it was just sort of our private project to talk about that. But in the meantime, we have taken that phrase, or probably, I don't know, marketing or the product teams or whatever, have taken this lovely phrase and used it to encapsulate something specific that we mean by Android development. And we're going to go into that today, talk about the surface area that we're talking about with modern Android development, cover some of those topics in a little bit more detail. And then, as Greg said, following this talk, we're going to have a panel with many more experts on the specific technologies of modern Android development that will be there to answer your random questions. So first, why don't we talk about what we'll call classic Android development?
So the opposite of what the talk is about, really. So let's start with the history lesson. You know, what happened with Android over the past 15 years or so. So at the end of 2007, that's when we released the first public version of Android. It was meant for developers. It was just an SDK called M3 for Milestone 3. There were a Milestone 1 and a Milestone 2, but they never saw the day outside of Google. And a lot of, if you look at this SDK, a lot of what you already know today was there. In particular, we're already using the Java programming language to write the apps, the framework, of course, all the platform APIs were written this way. We were using APKs to package applications. The biggest difference compared to today is that we were using a different IDE, so we're using the Eclipse platform, and we had a plugin called ADT, the Android Developer Tools, that we shipped on top of Eclipse to enable Android development. So then a year later, at the end of 2008, we released the first Android phone. So the first version of Android came out and was available to the public. And then for a bunch of years, not much happened, or I would say not much interesting happened for the context of this talk. Of course, like the teams, and we'll see that in a little bit, the teams were incredibly busy. We kept evolving the platform. We had new APIs, new features, but it was all based on those existing foundations that we saw in the SDK M3. The biggest change, the first big change, occurred in 2013 when we announced Android Studio. So we switched from the Eclipse platform to the IntelliJ platform. So first big change in the modern era of Android development. And again, it took us a few years to build on that new foundation. Not much interesting happened. Of course, a lot of things happened, but nothing drastic. Until 2017, so 3 years ago, when we announced support for the Kotlin programming language. That was the first time we added an officially supported language since Android came out. So that was a big change for us. We also, a little bit later, introduced the Arch component library. So we heard you as a community, you wanted like clear guidance, you wanted us to be opinionated about how to build an application. So we created this suite of libraries to help you do that. Of course, if you want to do it your own way, you can. This is just a turnkey solution if you don't want to have to think about it. And more recently, in 2019, we started tackling the problem of distributing the app. There have been like different solutions over the years, but app bundles is where it's at nowadays. And Chet will talk about that more at the end of this presentation.
So in classic Androids, so we're going to talk about different what we call pillars of modern Android development, and one of those pillars is language. Previously, on the language front, we had the Java programming language, a great solution to the problem of how to introduce a whole lot of developers to a new platform. Many developers knew and continue to know how to write code in Java programming language, so that's great. There were free tools out there like Eclipse, and other IDEs, so it was easy. We didn't want it to be a requirement that people spend a lot of money on a developer setup in order to write applications for this new platform. We wanted to lower the barrier to entry in as many different ways as possible. There was also a lot of existing practices that people would use and middleware libraries that they could use, the patterns of how they wrote their code. So again, making it easy for them to just transition over. Obviously, new APIs, new capabilities, new type of programming to a lot of those developers. But if they could at least use a lot of what they already knew and were comfortable with, then it made it easier to start writing applications for Android. Again, this seems a little silly now in the context of 2020, but at the time, this was, one of the important languages that you would use for automatic memory management. Compare that to C and C++, where you really need to very carefully manage your memory. And if you don't, you will regret it because it'll crash for you when you're trying to do things. Whereas Java programming language and now other languages since then will do all this through runtime and garbage collectors and just sort of simplify the programming effort in many different ways.
Right, so we mentioned Eclipse already. So again, Eclipse was this free open source IDE that was free, was one of the key, right? Like Chet mentioned, we wanted to lower the barrier of entry to write applications for mobile. And between the SDK, the emulator, and Eclipse, you could get started without spending a cent. So that was a very good thing for us and for Android, obviously. One of the huge benefits of Eclipse as well is it was an extremely popular IDE in the Java programming world. So it was used extensively for desktop programming, for server-side programming, and that meant that if we wanted to increase the adoption of the Android platform quickly, if we picked an IDE that everybody already knew, it would be a lot easier for them to get started. We already mentioned that it's free, very important for many developers out there. And it's part of trying to be inclusive, right? Like we tend to forget how expensive it can be to get started with programming sometimes. One of the benefits of Eclipse is actually the Eclipse RCP is a plugin platform. So there's an IDE that's built out of it, but you can extend the IDE using your own plugins. So it was very easy for us to integrate all of our tools inside the IDE UI, but at the same time, because the Eclipse RCP is this framework to build any kind of applications, we could provide those tools as separate standalone applications. So a good example was our profiler. So our profiler was available, it was called TraceView. It was available as a standalone application, but we could reuse it as part of the plugin system directly in the IDE using the same code base. And of course, Dimension Eclipse is free.
On the API front, one of the most important aspects of any platform, at least people who care deeply about APIs, as we do, there was basically the platform APIs. There were frequent releases. We'll see a timeline shortly showing exactly how frequent these things were. And each of those releases came with new functionality, new really important functionality, because the team was running really quickly to sort of catch up to where they needed to be, both for developers as well as for user functionality on these devices. And there were important bug fixes, because when you write code, you write bugs, and then you need to fix them, at which point you probably create more bugs. So you need to fix those. So all of these releases coming out all the time with really important things that developers needed because users needed them as well. So here's a quick timeline. You can see how quickly the team was running at the time. As Romain said earlier, 1.0 came out in late 2008. Shortly after that, 1.1 came out, mostly bug fix release, then 1.5, the Petit Fort release, and then 1.6. And you can see not only are these releases coming out within, a short number of months from each other, but actually they tended to be developed in parallel. So the team tended to work on 2 and sometimes even 3 releases in parallel, just racing and racing and racing to get these things out there. 2.0, just short of 2010, then 2.2, then Gingerbread came out late 2010, then Honeycomb, and then eventually the team slowed down to what is now typical annual cadence, and everybody breathed a big sigh of relief, including the team, but also developers and users and manufacturers and partners, because it's difficult for everybody to sort of keep up with this manic pace and introduce all the new functionality into your devices that you're shipping or into your code for the apps that you're shipping. So we've gotten into a little bit more regular cadence since then.
All right, so I already mentioned APKs, which is the way we distribute Android applications. APKs are just zip files with a different extension name, and of course, like some convention of what should be present in that zip file. It made it very easy to create the applications, to also peek into the applications, see how they're made. But there was an issue that actually wasn't an issue when we started Android. So when we started Android, like all the phones were pretty much the same. Apps were pretty small. I don't remember the exact size, but I believe the entire operating system in 2008 was about 64 megabytes. And today, like it's pretty common to find applications that are way bigger than that. So one of the problems with this solution was what to do when you have to support multiple configurations. So for instance, when we introduced tablets, right, you would have a different UI for your tablet that you could customize for that, or when you want to support multiple densities or many, many languages. So the only things you could do was either create more APKs, which obviously was difficult, and you had to like handle all of that yourself, or you had to create bigger APKs, which didn't make a lot of sense because that meant that someone would end up with an APK on their phone, they had to download it, they had to store it, and it would contain a ton of data that they would never, ever, ever use or need. So that simple APK system was great for what it was meant to do at first, but it clearly wasn't enough as the platform evolved.
So we talked about the classic way of doing things. Now we can talk about some of the problems that came from that. We've alluded to some of these problems already. On the language front, we did have this lovely Java programming language. Still a good language, but it is, especially when you compare it to other more modern approaches, verbose, right? You end up with a lot of boilerplate code that you are writing and reading and maintaining over time.
Yeah, sorry. So we mentioned before using Eclipse was great because this was this really powerful platform, plugin based, it was free and all that, and we could customize it. Now, one of the issues with Eclipse, that despite the fact that it was designed for customization, it was actually difficult to do so. And the different plugins that constituted the IDE were handled by different groups or different persons, and we didn't have control, or we had even potentially no influence over some of those bits. So for instance, if we wanted to improve the Java programming language editing experience, this is not something we could do easily, because that part of that plugin was handled by a different company, and they could just, ignore what we wanted because that's their plugin after all. It also meant that the experience could be slightly inconsistent because you had all those plugins and nobody was really in charge of making sure that all the UIs and interactions were the same across all the subtools. So we could do that for our own tools, but again, we had no control over the rest of the IDE. So it proved to be kind of an issue, especially over the years, as Eclipse focused more on being an application platform, which made a lot of sense because it was and it is very successful in doing so. But it was not where we wanted to go. So that was really an issue, and that's what led to Android Studio later on.
Many were the discussions I remember having at the time with the tools team, like Xavier or Tor, where I'd say, oh, I just hit this following problem. Wouldn't it be nice if the UI did, such and such instead? And the answer typically was, that's a part of the platform that we do not control. So we can't customize that experience to be what would be a much better experience for our developers. On the API side, the platform, as I said, is where all the APIs lived, which was great. They're all in the same place. You don't take up space in your application for this functionality. Instead, you just depend on the platform. But it also depended on users actually getting those releases. So the developers might be excited about those new features or those wonderful bug fixes that came out in the latest release. But if their users didn't have that release, then they couldn't count on it. Then how much effort should they devote to that new release instead of fixing problems on their apps on older releases? And more we would get the response from developers of, I'm not interested in that feature for another 3 years because that's about the time frame that my users will get it. So it was really difficult for developers to adopt these things into their applications. It would make for a much better experience on the phones, and it was much better for us on the platform side to then, evangelize these things and work on this exciting new functionality, knowing that there was going to be this spread of adoption throughout the ecosystem, because most of the users were on these older releases. Because one of the great benefits of Android is that we do not control the ecosystem. That is what makes it encouraging to all these other companies to ship based on the Android operating system, but we don't control those people, right? That's the flip side of that relationship. It's what made it such a popular approach in general in the ecosystem, but it means we don't have that lever to control when the users are going to get this stuff. Also, some of the APIs were necessarily complicated. I think a lot of this is necessary because it's a complicated space. If you're writing a server app, it tends to be sort of single focused on this thing. Desktop, maybe you have dedicated resources for achieving your goal. On mobile, you have not only constrained resources, you have a battery that you really don't want to use up. You have a small screen. Typically, you have multiple sizes of screens, so you need to deal with the format situations. Also, just an infinite amount of stuff you can do. Do you want to run something locally, like a game? Do you want to talk to the server? Do you want to deal with, bandwidth issues? Where do you store the information? Like everything, right? You can do everything on these devices. So it's kind of a complicated space. But also, some of the approaches that we took in the early days tended to be driven by the constraints of the device. So we had APIs that were really built around, don't ever allocate because then you're going to have to free and you're going to cause jank when the GC kicks in. And so we had some API surfaces that were a little complicated, quickly written because the team was running really quickly. And we built up some baggage over the years of things being hard to write applications for. And that includes areas like the life cycle, when applications or activities are being created or torn down in the background so that the operating system can, share and multitask in an intelligent and transparent way. Storage, where do you put these things and some of the permissions associated with that. Navigating through the app, the back versus the up button. The back button was like this really awesome thing that Android had from the beginning, but the implementation of how that actually worked in applications tended to be somewhat inconsistent.
And speaking of things that are difficult, we already mentioned APK. Again, part of the problem was when you wanted to handle multiple configurations, multiple types of devices. So either, again, you used a monolithic APK that handled like everything at once. So that meant bigger downloads, which users didn't like, bigger storage. Again, some users like storage was an issue on a lot of devices back then. Or you had to split your application in multiple APKs, which was a complicated process, and you had to do it yourself by hand. And actually, at the beginning, the Play Store or the Android market, as it was called, did not even have support for multiple APKs. So you would potentially have to upload your application several times under different names, and different package names, which was not a great idea.
All right, so we believe the answer that we have iterated toward is what we are now calling modern Android development. And I took the time to write down a sentence for it, so I'm just going to go ahead and read it because it encapsulates the ideas that we have. It's development tools, APIs, language, and distribution. So those are the four sort of pillars that we're talking about here. Technology is recommended by the Android team to help developers be productive and create better apps that run across billions of devices. So there's a lot of different aspects of this, basically making it easier through things like the architecture component. Stuff that we're talking about, billions of devices means we're talking about unbundled libraries and approaches here. So you're no longer sort of hinged to the platform and dependent upon when users get those releases. So we're going to walk through these different pillars here in the rest of the talk. We're going to talk about language and tools and APIs and distribution. You can also imagine we're not replacing the traditional tools you use on Play or the traditional APIs that you have in the platform. In many cases, we are recommending to use the unbundled approach instead. So use lifecycle and view model and stuff like that instead of dealing directly with activity lifecycle APIs. But there's still a lot of fundamental things on the platform that you will use anyway. We're not talking about those. We'll just sort of take that as read. But instead, we're going to talk about these things that sit on top of there in the unbundled libraries and approaches to make your development lives easier. Starting with.
So Kotlin, new programming language. I assume this is where I wish that we were at a real conference, an in-person conference, so we could ask you to raise your hand so we could gauge how many people are using Kotlin. Are you really using Kotlin, Chet? Or do you
I am. Yes, that's 100% of the people that you can see in the audience. So pretty good.
I'm proud of you. So let's do a quick recap on the timeline for Kotlin on Android. So Kotlin 1.0. So Kotlin started 5-6 years ago, something like this. It's a programming language by JetBrains, who also makes IntelliJ, which powers Android Studio. And in 2016, they released Kotlin 1.0. After that, we saw, the community was already talking about Kotlin quite a bit, and we had been looking at Kotlin internally ourselves. We found it very interesting. But we saw that it was getting more and more popular with Vue app developers. And we started talking about it even more seriously internally. And after many, many discussions, we decided to make it an officially supported language in the platform. What this meant for us in 2017 was that we would guarantee that we would not release new SDKs or new version of Android Studio that would break Kotlin, because that was happening from time to time back then. So at that stage, we were not going to rewrite our APIs or our SDK or our framework in Kotlin or anything like that, but we just wanted to make sure that if you adopted Kotlin, you could be confident that you would not certainly lose hours of work or days of work just because of an update on our side. And we try to be careful with these kind of decisions because they have a big impact on the community. So we waited a couple of years and we did a number of things in the meantime to support Kotlin better, right? We added better lean support and stuff like that. We're going to talk about it in a minute. But what this meant was in 2019 at Google I/O, we announced that we're officially going Kotlin first. We are not abandoning the Java programming language. It's still supported. And as a matter of fact, it's still most of the development on the platform itself is still done using the Java programming language. The framework itself is written in Java. The public APIs are written in Java, and they will probably remain that way for quite a while. We started using Kotlin internally in areas where we don't expose APIs. to avoid compatibility issues, especially with the standard library. But otherwise, it's mostly Java. What it means for us going Kotlin first is that when we introduce new APIs in the platform, our API console makes sure that those APIs play nice with Kotlin, that they are easy to use from Kotlin. We also create a number of extension libraries for the platform and Jetpack libraries. We started writing new libraries in Kotlin, and again, we're going to take a look at that. That also means that, on the DevRel side, we've been focusing on having more training, more code labs, more documentation, anything that one might need to get started with Kotlin, especially because so many people out there have a lot of experience with the Java programming language. We recognize that it can be difficult to onboard someone with Kotlin because it was a lesser known language. Although, as you can see with this screenshot of a slide from a year ago, adoption is really, really fast in our ecosystem. And this year, there was no Google I/O, but around the time where Google I/O would have happened, we announced that coroutines are our preferred way of doing asynchronous programming. We had various solutions in the past that were more or less successful, but now we're saying, look, you should be using Kotlin and you should be using coroutines. Again, you don't have to. You can use other solutions. If you want to use Java and just an executor and a bunch of callbacks, that's completely okay. Do what works for you. But we think that this is a good way to go. So that's where we are. And now we just want to talk about a little bit about the decision of why we pick Kotlin. So there are many reasons, but there are 4 important ones. So first of all, it's a very expressive language, maybe sometimes to a fault. So it lets you write code in a more concise manner, so that code is easier to read, easier to write, easier to maintain overall. It comes with increased safety. It has a strong type system, and in particular, there's nullability at the language level. So a null type is a different type than a non-null type, and we saw the numbers. I don't have them in mind, but we saw a huge reduction in crashes overall and an increase in users liking applications that have adopted Kotlin. It's easy to make those mistakes as programmers, and there are ways with Java to work around those, but they require a lot of external tooling, and Kotlin just does that at the language level. So in the IDE directly, when you're doing something wrong. Interop was extremely important to us. What this means that if you want to adopt Kotlin, you do not have to rewrite your application, and that was key for us, right? If you want to adopt Kotlin, you haven't done so, tomorrow the next class you write, the next file you open can be written in Kotlin, and you can leave the rest of the application as is. And over time, you can start rewriting your application slowly as you maintain your code. So that was extremely, extremely powerful. And that also means for us, we can keep writing, like I mentioned, Java APIs in Java in the platform, and we know that they will be available to both Kotlin and Java users. We don't have to write a bunch of boilerplate or generate special bindings. Finally, I mentioned coroutines. So structured concurrency is something that JetBrains has been working on a lot. You have coroutines, you have flow, and it dramatically improves the experience of trying to write concurrent code or just asynchronous code. It's safer, it's easier to read, easier to maintain. So some example, if you're not using Kotlin, we're going to try to sell you on it really quickly. So let's take a look at this beautiful, simple example that Chet wrote. So it's a simple activity that sets up a click listener. So first, you can see at the top, there's a nullable type. So the saved instance state that you receive is a bundle ? I guess it's a bundle. And that means that this object may be null. Without the question mark, it's not, and that's the compiler will ensure that you're treating the object accordingly. Then we have support for lambda. So lambdas are nothing new, right? But one of the great things that Kotlin did was this little syntax trick where when a lambda parameter is the last one for a function or method, you can pass the lambda as the body, basically, of the function. So instead of passing the lambda inside the parentheses of a function call, you can just open the curly braces and put the content of your lambda right there. It's easier to read visually, but it also opens the door to many interesting things with DSLs, for instance, and this is also something we lean on heavily for Jetpack Compose. Without this very simple feature, Jetpack Compose would not be the same, and I'm pretty sure I would not like it. Extension functions, also a great feature, again, existed in other languages before. It's just syntactic sugar. It's basically at the runtime level, it's a static function that takes, in this case, name.capitalize. Name is a string. So there's a capitalized static function that takes a string as a parameter. But there's syntactic sugar where you can invoke that function as if it was a method declared on that type, which greatly changes the way we write APIs, especially for libraries. So now we can keep the types as simple as possible, like focus on their data. And all the operations can become, or most of the operations, as long as you don't need things like overloading or overriding, can just be extension functions somewhere else. It was also very powerful for us because we were able to create extensions for existing APIs, like platform APIs, to make them better and easier to use from Kotlin. We're going to see an example in a little bit. Template expressions, again, nothing new, but it's great to have all those features together. You don't have to concatenate strings by hand. Property support, so when you have setters and getters, instead you can just access the property with the property syntax as if it was a naked field, but you have all the safety and guarantee of using setters and getters. And there's many, many other things. So one of the other benefits that we see with Kotlin is speed. And we're talking here about the speed of development, so how fast you can write your code, but also the speed of the language evolution. The language is evolving rapidly, which makes sense because it's pretty new. So for instance, coroutines were experimental a year ago, now they are fully supported. Flow appeared, and Kotlin itself is gaining new features rapidly, which is really nice for us in the community. And again, there are things built into the language, like the way you can write lambdas and extension functions that kind of lets you extend the language in a way. It's not really language extensions, but it feels like it when you're using them, which makes it easier to write libraries with nice APIs. And like I said before, Kotlin has been very successful for us and the Android ecosystem. So as of May of this year, 60% of pro Android developers who publish apps on Play Store are using Kotlin. And if we look at the top 10,000 most downloaded applications on Play Store, 70% of them contain Kotlin code. And I'm sure if we looked at those numbers now, because that was 6 months ago, they would be higher than that. So I assume that 70% of you are using Kotlin, and if you're not using Kotlin, I strongly encourage you to take a look at it. I mentioned we are Kotlin first now. So on the tool side, we've done a number of things to help Kotlin developers. So we have new lint checks to help you write better Kotlin code. We have a dedicated compiler team. So R8 is our DEX optimizer that can be used with Java as well. It's not specific to Kotlin, but we've done a number of optimizations that are Kotlin specific. We looked at the code that gets generated by the Kotlin compiler, and we applied optimizations to make that code better. We also improved annotation processing speed. We recently introduced something called KSP, the Kotlin symbol processor. So if you want to do annotation processing, you should look at KSP because it's going to be faster than KAPT. That also means that our compiler team works closely with JetBrains. So we do contribute a lot of features and bug fixes to the Kotlin compiler itself. We are deeply invested. On the platform side, we've been annotating our platform APIs using the @nullable and non-null annotations because they help inform the Kotlin compiler about what types are nullable or not. This is kind of a workaround for Java. We also have this recently nullable and recently non-null. So normally, if you misuse one of those types, you're going to get a compiler error. When a type is recently nullable or recently non-null, you're going to get a warning instead. And then later on, we can switch the annotation to be the non-recently version, and then you're going to start getting errors. So it's a way for us to get you prepared to changes. We've also built a number of Kotlin extension libraries, so what we call KTX. We started with extensions for the platform. Now a number of Jetpack libraries have them. Just a way for us to make the platform APIs easier to use. So we're going to take a look at an example. If you look at the bitmap API, there's a create bitmap static function on the bitmap class. It takes a width, a height, and a configuration, the type of pixel you want. Then there's the drawable API, and on drawable, you have this draw method that takes a canvas. That's how you draw your drawable onto a canvas. And if you wanted to convert a drawable into a bitmap, you need to create a bitmap, create a canvas for that bitmap, and draw that drawable onto the bitmap. So you can see the kind of code you would write here at the bottom. You can see that you need to save the bounds of the drawable. if you're on the first line, you can see the destructured assignment of a rectangle. That's another nice feature of Kotlin. Anyway, so you create a bitmap, you create a canvas for that bitmap, you draw your drawable, and then you restore the bounds. It's not hard, but it's a lot of boilerplate, and I'm sure many of you have done that in the past. Now, in our KTX library, we have this extension function called toBitmap on drawable. So it takes a width, a height, and a configuration. And as you can see, it provides default parameter values, so you don't have to specify yourself what it is you want. Like most of the time, you will probably draw the drawable at its intrinsic size. So we use those as the default values. And your app code turns into what you see on screen to just a single line where you say drawable.toBitmap, and you can optionally specify the width and the height. So this is just a small example. We have many other APIs like this that make Android development a lot nicer when you use Kotlin. On the library side, we started like building Kotlin-specific APIs that are still compatible with Java. So we have support for coroutines in Room and Work Manager, for instance. Paging, the paging library in paging 3.0 was rewritten to be written entirely in Kotlin. And of course, we have Jetpack Compose, our next generation UI toolkit. Not only is Jetpack Compose written entirely in Kotlin, but it relies on a Kotlin compiler plugin to make changes at the language level, if you will. We introduced the concept of composable functions that are akin to suspend functions in many ways, if you're familiar with coroutines. This is not something we would have been able to do with a Java programming language, for instance. And also, that's more on Chet's side of the world, but like I said before, tons of resources to help you, right? So documentation, new samples, best practices for Kotlin, code labs, courses, articles and videos. There's this Kotlin vocabulary series is that still going on, Chet?
Yes. Yep.
Right. So yeah, Florina has been doing those. So just a nice bite-sized way of learning like the ins and outs of the Kotlin programming language.
And now,
yeah, sorry, just I'm talking for a while. Need a drink. And now onto the tools. So Android Studio, we mentioned Android Studio before. A quick history lesson. So Android Studio was introduced in 2013. We announced it at what I assume was Google I/O. But we kept supporting Eclipse because most of you were still using Eclipse, obviously, at this time. At the end of 2016, we officially deprecated our edited plugin, and the amount of support we were doing had been going down anyway. 2.2, that's when we introduced also Android Studio 2.2, which was the introduction of the constraint layout editor. And it was the first time we built a library at the same time as we built the tools. Actually, the engineers who built the library are the engineers who built the editor at the same time to ensure like the best possible support in the tools. A year later, 2017, we had Android Studio 3.0 with official Kotlin support and a bunch of new profilers. So we had TraceView before, there was systrace. There was a profiler in Android Studio, but it was limited, so there was a big effort to rewrite those. So you had a CPU profiler, memory profiler, and a network profiler with a really nice and easy-to-use UI. In 3.1, we added support for D8, our new compiler that compiles directly to text code, so it's faster and more optimized. In 3.2, we expanded on our profiler support with the energy profiler for battery, and also we integrated systrace. So before you had to use it from the command line, it was a little janky, so now you have a nice UI in Studio. In 2019, we added the navigation editor. So again, it was designed by people working on the navigation library in collaboration with the engineers on the tools team. 3.6 that came out this year introduced view binding. A lot of you were using data binding to replace find view by ID. View binding is a nicer, more efficient way of doing that. And I think we're missing the latest versions of the platform. Yeah, so 4.0 that came out earlier this year introduced Motion Editor, which builds on constraint layout and the constraint layout editor to give you an animation authoring tool inside Studio where you can preview your animation, you can create multiple states and stuff like that. And of course, 4.1 is out now, and 4.2 is coming with many, many more features. So Android Studio is built on the IntelliJ platform. It gave us a lot of really good benefits. IntelliJ is great at code refactoring. It has many, many incredibly powerful refactoring tools. The UI is extensible. It's less there's less freedom than in something like the Eclipse platform. But it's extensible enough for all the things that we want to do. We work with JetBrains very closely, thanks to the work on Android Studio, which is nice because we work with them closely on the Kotlin compiler. So there's a lot of things that we do together. Like, for instance, Jetpack Compose. Recently, they announced Jetpack Compose for desktop. So you see a lot of synergy between the two companies, and it's been going really well for us. Studio IntelliJ already had good support, obviously, for Kotlin and for Gradle, so we also benefit from that. Lean check, quick fixes, again, like a framework that's part of IntelliJ. We built upon that to bring you our own Android-specific support. And you may have noticed that a couple of times I mentioned that we try now to build libraries and tools at the same time. I mentioned constraint layout, I mentioned navigation editor, but we've done that for data binding, for Room. There was the database explorer that was introduced earlier this year. Same thing, it was done in collaboration between the Toolkit team and the Studio team. So a lot of good has come out of trying to build libraries and tools at the same time.
All right, now let's talk about APIs, which you can think of as mostly Android Jetpack, or more specifically part of Android Jetpack. Jetpack is huge. It's like over 80 libraries shipping, every couple of weeks, everything from compat stuff to biometrics APIs, like all over the map, just giving you unbundled ways of accomplishing lots and lots of things. But when we think about modern Android development, we're really talking about mostly a subset of that. I think of it as sort of mostly the architecture components is when we took a big step back and said, what's really difficult, and then created libraries and APIs specifically around that, as well as some of the tooling stuff like constraint layout and motion layout. So if we look at the modern APIs timeline, constraint layout is sort of where I think of this as beginning, and then the introduction of the architecture components, specifically life cycles and view model and Room, and then we've had many more since then. At Google I/O in 2018, we announced Jetpack, which was sort of collecting a lot of these unbundled things together into one growing surface area of APIs. And then we also introduced the paging library, sort of streaming data into recycler views, navigation library and tool, as Romain mentioned before, and work manager as well. And material design components came out. So before material design components, we had a design spec, which was really helpful because then it gave developers something to look at and say, okay, how do I make my app and design more consistent? But we left a lot of the details up to you as to how to actually accomplish that. And material design components makes that a lot easier. So you can use the built-in components to sort of get that look and feel out of the box. And there's been more development since then to make these more consistent, more powerful as time goes on. And Google I/O in 2019, we announced Jetpack Compose, which was then being developed in the open. It has since gone alpha and is still under development, so not released yet, but it is getting there. And Camera X as well, which is still in beta, and I'll talk about that a little bit later. And then Motion Layout and Motion Editor came out. Motion Layout had been out in an earlier version for a while, but writing XML code to do complex animations is a little difficult. So using a built-in tool to access that API makes it a really powerful solution for getting really rich UI animations that can be nicely integrated into user actions in the UI as well. So we're going to look at some of these things, tools, but mostly APIs. So constraint layout, I think of this as being kind of relative layout plus, which is it's the same ability to lay out your UI widgets, your views relative to each other and relative to containers, but even more than that. So we'd long since had this idea of these key lines or these guides. You've got this 8-dip margin on the sides, and you have this regular grid of 4 dips or 8 dips throughout the UI. But how do you actually do that in an easy way as a developer? And now all of a sudden you could have a way inside the tool of laying down these virtual lines and then aligning views to those things as well, and aligning things to each other. So just a much more powerful approach, and more importantly, tightly integrated with the visual tool. So we'd always had a visual tool. It didn't always do what you thought it should, especially since you were probably using many different layouts in your application, and the support for them was a bit scattershot, whereas the support for constraint layout is really tight and tightly built with the same people that are working on the API and the tool in concert together. Motion layouts is a subclass of constraint layouts. I think of this as being transitions plus. It's the same sort of mental concept of saying I have a before state and I have an after state, and then I'm going to run an animation between these things, and it can figure out those changes automatically and run that automatically as transitions does, but it has access to many more properties that can automatically animate for you, and more importantly, it allows you to customize the animation, so you can really make this very custom experience for the user using the tool or the API directly between these before and after states. On the lifecycle side, so before our architecture components, we had this lovely diagram that you would really need to memorize, and it's actually much more complicated than this. And you really needed to understand it very tightly because of a couple of problems that were very frequent, if you don't really get it well enough. And one of those is you could leak an activity, and then pretty soon you're running out of memory because you didn't realize that something was no longer in life cycle, and yet you held on to something that is keeping it there, and therefore you don't have any more resources available. Or maybe that activity has died and you refer to a resource in that activity, and now you crash. And so you really needed to understand when was the application being started, when is it paused, when is it resumed, when is it stopped, and understand when these things happen and what implications that has for your application. In order to do that, you wrote code that looked a little like this. So we ended up with applications that would stuff a whole lot of code in their activity, because that's kind of where you needed to start to get all this information you needed to override activity or app compat activity, and then override these methods or functions so that you could find out, okay, when does this lifecycle event occur? Because it was the only way to get that information. So now the new approach is don't do that. Still have a good understanding of general lifecycle stuff, but we're much more flexible in how you interact with the system to get that information. So now you can actually observe and you can find out about lifecycle changes without stuffing a whole bunch of code into your activity. You no longer need to override those functions in order to get it. Instead, you can just register an observer, and app compat activity as well as fragments allow you to observe these changes automatically. So you can observe on those and then get callbacks to find out when the things occur. Or even more interestingly, you can query and say, what state am I in? Which strangely you could never do before. The system knew what state you were in, but we kept it as a closely guarded secret, and now we will let you in on that secret. So then we iterate toward an application model that looks something like this, where it's now easier to separate the concerns of you have your user interface code where you update the views on the screen, and the updates are based on data, but you really shouldn't do them all together. You should really segregate your data from your user interface and deal with these very separately. And now you can do this through the observer model. So you have the data sitting over there, you have a view model, publishes live data information, so you observe on that, and then when that data changes, you will get a callback, and then your UI can update appropriately with the data that's changed. We can extend that using something like Room. So you have this DAO sitting on top of the SQLite database. And then again, you've got this data model you can observe on, get changes when things happen in the database, and then update your UI accordingly. The DAO has these functions that you then implement, which are suspend functions, which makes it a lot easier to deal with a necessarily multi-threaded approach that you have to have. When you're dealing with UI as well as database, you're going to be dealing with at least 2 threads, right? You should not be doing database queries on that UI thread. Instead, you need to send it over to a different thread. Well, then it kind of quickly becomes spaghetti code, because you need to send it over there, and then you need to find out when it changes, and you need to get the data back, and how do you carefully organize who's doing what on which thread, and when is this all happening. And suspend functions make this much easier because they can sort of automatically send it over to the right threads and make it much easier to write the code that is doing that is calling these suspend functions, and make it much easier to read and then to reason about what's actually going on in this somewhat complicated logic of sending this information back and forth between the threads of the system. Similar approach for paging, where instead of just sharing these individual pieces of data from your database, you can actually share an entire list, paged list, which is really important for paging, specifically because you're streaming data, this chunk of data that's going to go into your recycler view as you're quickly flinging it along. One of the interesting things about all of these APIs is that they're really built to work together. So ViewModel, live data, they're all lifecycle aware, so they're all sharing these similar concepts. And it allows it to be easier in your application code to avoid leaks because you're using the same approach across all of these different APIs, the same concepts of life cycles and liveness of data. So there's other examples. So Room, you can access that via the view model and live data objects. Makes it easier, as I was saying before, to separate that the data in your database from the UI and do the right thing with the threading model at the same time. Room has APIs that use coroutines and flow. So for Kotlin developers, it's much easier to interact with this stuff in a much more elegant API that makes the code more readable and maintainable. I should point out too, I see one of the questions on the slide, and we'll probably get into this in the panel later, that's the architecture components are also RxJava friendly. The intention was not to replace the approach that you're using. If you're using RxJava, if you love RxJava, awesome. Go ahead and keep using it. That's fine. The intention was instead to capture some of the specific elements that were making Android difficult to develop for and forcing people to use a larger framework like RxJava to accomplish these things. It does not replace all of RxJava, and it is not intended to. Instead, it replaces specific elements of that approach. And if you're not using RxJava before already, then maybe it's easier for you to use this. Because then you don't have to take on, the RxJava programming model throughout your application in order to do that. On the other hand, if you're already using RxJava and it's throughout your code base, maybe it's easier to sort of leave it there, which is why we expose APIs that are RxJava friendly so that you don't have to convert to, our system and our mental model of how this works in order to just keep maintaining and developing your code. Let's see. So navigation component is an interesting library API in a couple of standpoints. One is that it vastly simplifies the idea of navigation. So you now have this idea that you can navigate through the different screens, the flows in your application, and you can have a tool to help you do that. So this was typically a little bit complicated to get a mental model of how it all worked, much less the code. And the navigation component APIs, as well as the design tool, make all of that stuff easier. So you can use new templates in Android Studio, I think starting in 3.6, when you create one of several activity types, including basic activity, then it gives you navigation capabilities built in. So that's sort of where I start from. If I'm building an application where I want navigation, I'll use one of those templates. And then, it's not the templates, it's not the functionality I wanted, but then you have at least all the boilerplate built in, all the capabilities and dependencies already there, and then you can extend from there. So you create this basic activity, and then it gives you this to-destination application that allows you to then go back and forth between these. Now, this being an Android Studio tool, that means that there is underlying XML code here, so you can take a look at that. And here, basically, the two destinations that we see are both fragments, and they have actions declared on them. And the actions are really those arrows. It's not navigating from first to second or second to first, but rather saying this is a direction of navigation, and then the runtime code actually triggers the navigation. We can see that. So here, maybe in an on-click listener, you want to navigate using one of those actions, which will take you from one destination to another, and then you refer to the resource that was created on your behalf when you're using the design tool. There's some other things that are really nice about navigation, including safe-arg. So typically you want to pass data between destinations. So destinations may want to share data. Maybe they need shared access to, database or some information about the state of the application. It's nice to not just have a global, some singleton somewhere that everybody has access to, because it's kind of better to encapsulate your data and keep it where it should be and not share too much between too many different moving pieces. So passing data is a really good way to do that. And the typical way to do that between activities and fragments is bundles, but that's not a type-safe way to do it. And it's kind of a tedious API to use for passing simple bits of data. And so safe-args exists to simplify all of this stuff. So it makes it easier to create the bundle that you need on the passing side, and then on the other side where you receive the data, makes it easy to extract the data from the bundle and to do all of this in a type-safe way. It also makes it easier to create these single activity UIs. So the traditional development model for Android was always multi-activity, where you go from this screen to another screen and it's going to pop up a new activity window and you have this nice window animation. It's a bit of a dated look, but it also makes it hard to encapsulate shared UI, where maybe you want to have the same Chrome in these different screens of the application, and there's really just some inner content that you wanted to change. Well, it's going to be a better user experience to actually just keep the same window on the screen and then change out the inner content instead. So that's what we've been recommending, but we didn't necessarily make that easy. And the fragment APIs by themselves probably aren't the simplest way to approach life in general. And so navigation simplifies a lot of that stuff and builds in the capabilities that allow you to sort of swap in and out the fragment content within your single activity in a much, much easier way. Also, up versus back, I alluded to this before. We have this awesome back button capability in Android, always have. And then we have this up button, which is kind of the same, but a little bit different. And it's a little hard to understand what exactly you were supposed to do and how to implement this. And then it ended up being inconsistent. And if you use navigation, it gives you a consistent experience for both of these, just sort of built in. And there's also ability to support dynamic features. So you can actually navigate to a destination that doesn't even exist on the device yet. If it's a module that is going to be dynamically downloaded and installed, then when you navigate to it, that can be a trigger for the system to actually do the download and install on the fly for you. Let's take a quick look at Work Manager. I'm going to start running through the slides here because I realized we've gone on longer than I expected. Work Manager allows you to run the deferrable work. I really want this to happen. It doesn't have to happen immediately, so please schedule this thing to happen when it is convenient. It doesn't replace Alarm Manager per se. Instead, it's sort of a replacement for code that all applications were already writing. Like, you really want to use Job Dispatcher, but if you're not on the right release, then maybe you want to use some Play Services approach instead, or a Firebase approach. But if you're not on a device that has Play Services, then maybe you're going to back off to Alarm Manager, and basically encapsulates all of that and gives you a single API to deal with. And then based on the runtime situation on a device, it will make the right decision about how to accomplish that work. And it does that all the way back to API level 14. It supports periodic tasks. You can chain these things together. You can run them at the same time. Let me take a quick example look here. So let's say we want to run 3 different filters on images, but we don't want to do it if the battery is too low. We then want to compress the results when all of that is done, as long as there's enough storage, and then we want to upload the result of that, as long as we're on a network that's not going to charge money for that upload. So we create the work here using one of the APIs for Work Manager. We can create the constraints, and we can say, I don't want to do this thing when the battery is too low. Then we can create the filters and associate the constraints with it. And then we can create the actual work and say, well, I want to do all of these filters at the same time and enqueue them, or maybe when they are done, then I want to actually compress. So then you can see how we can structure the parallelism as well as the sequence of events that we want to happen and integrate all of these with constraints along the way. Work Manager also supports foreground services, which are increasingly important as we tighten the permissions for protecting user data and transparency of how things are being used. Camera X, really quickly, popular library, even in beta form, because it makes it much easier to write these camera applications, especially in a world with a diverse ecosystem where devices have different camera capabilities and applications ended up having to work around different ways that different devices would operate on the camera front. So they put this in a single API, and they put some of those workarounds in the library itself. Similar to Work Manager, you call one API, and then the API does the right thing. It also has this this model of these use cases, so it doesn't do everything that the Camera 2 API does, but rather it does the most important and the most popular things that most developers want to do, and then it has a much simpler API for doing that. It also just makes assumptions about the ways that you want to do things to make it easier to write. So in this simple code examples here, you can see you ask for a target resolution size. Well, in the Camera 2 or Camera 1 world, you would ask for this, and the device may not support that. And then you'd have to iterate through a series of choices and make a call in your code as to what you wanted. Camera X will do that for you. You ask for the target resolution, and it will come up with something that is good enough. It will try to get that exactly, or it will come up with whatever it can that is close enough to what you asked for, which is probably what you want. It makes it easy to bind a life cycle, so you don't have to be chasing down, did I open and close this resource at the correct time? And then there's simple APIs for, in this case, taking a picture or analyzing the results or whatever. Meanwhile, APIs, they're released frequently. Every couple of weeks, there's new releases with bug fixes and new functionality. There's APIs in development all the time, like some of the stuff we already mentioned. And then finally, quickly, I want to talk about app bundles, which we referred to before. Timeline, we launched it in 2018, and that's the timeline. There's a reality in the world that developers need to be aware of that many users do not have much space on their phones. And that directly affects your applications. The less space they have on their phone, the more likely it is that they're going to uninstall your app, especially if you have a large app. At the same time, the larger your app is, the more likely it is that there is going to be some issue in either downloading or installing that app. So the bigger it is, the more chance there may be of some failure at install time. And at the same time, if you actually make a smaller API, there's data that says that you actually will get increased installations, because then it's easier for the users to actually make that choice to install your app because they have enough space. App bundles, I like this visualization of it, where if you look at the APK on the left, basically a monolithic APK installs everything, right? It doesn't have a choice. It just gives every user every little bit of that thing. With dynamic delivery for app bundles, it can look at the user's device and say, okay, what are the configuration pieces you need? What locales are you running on the device? And therefore, I'm going to create an APK for you on the fly. And those are the only pieces that you get. The different ways of visualizing this thing. Pretty good adoption so far, over 500,000 of these things in production right now. Pretty good uptake. There will be even better uptake next year. I think second half of 2021, this is going to be a requirement for new apps. It is currently optional, but we do encourage you to take advantage of it soon. Start playing with it because look at this number. So on average, you get a size savings of 20%, basically because the APKs are created automatically for you. So you don't have to manage all these things. You just create essentially a monolithic APK, except it's a monolithic app bundle. And then we create the device-specific APIs for you and serve those out from the Play Store. So we've had a really quick run through in these 4 different pillars. On the language side, it's Kotlin. On the tools side, obviously Android Studio and all the sub-tools in there. APIs, essentially Arch components, plus the layouts mechanism we're talking about, and material design components, as well as Camera X. And on distribution, it's about Android app bundles. There is a site with more information, modern Android development, on d.android.com. And also, there's a series of technical videos and articles that we've started producing. First series is on navigation. There's a series in app bundles that is ending this week with a Q&A on Thursday. You can check out this site for links to all of that content. And that is it. Thank you. I see that there's a lot of questions in the Slido, or a few questions already, which is awesome. And then during the Q&A, keep asking questions and we will get to what we can. And I think that talk begins in 7 minutes. It's that awkward part where we realize that we disconnected halfway through and nobody can hear us.
Yeah, as long as we can keep talking in our microphone. Does it matter, Chet?
It doesn't.